Hi everybody, my name's Derek Bingham. I'm a developer advocate at AWS, and over the next 30 minutes I'm going to show you how to build a cross-platform, offline-first application using Flutter. Today, application acceleration is key. Whether you're building the application across many different platforms, or, like we're doing today, building it with an offline-first paradigm, whereas the application will work seamlessly whether it's connected or disconnected, which is traditionally quite complex and would slow down your application acceleration. And we all know that application acceleration is very key these days because we have to get that application in the hands of our users as quickly as possible so they can be delighted by the features that we're building for them and also provide us feedback. But building cross-platform apps can be difficult because we have multiple code bases. But what if we had a single code base? And also, building offline first has its own complexities. Complexities like how do you determine connection state changes and then reflect those changes into your application? Or when your application changes from connected to disconnected state, how do you sort through problems like conflict detection and resolution of the data that your app is storing? Also, complexities around having to be able to seamlessly sync data across clients. So if client A is running on an iOS device and client B is running on Android, they want the same representation of the data and they want it as fast as possible. So if client A makes a change, client B wants to see it as quickly as possible. And then finally, all of the scaffolding code and the glue code that you traditionally have to build inside an application, it slows you down and it all affects your application and the acceleration and application acceleration. And why? Because we as developers want the maximum time to work on the actual features that delight our users, the features that will distinguish our application above all the other ones in the market. So today I'm going to show you how to do that. And we're going to start with Flutter. What is Flutter? So Flutter is a cross-platform SDK that runs on Android, iOS, web and desktop. It is first released in 2017 and is slowly gaining traction and momentum across all developers who want to build web and mobile. The reason I think that it's gaining such traction is its developer experience is fantastic and it uses the Dart programming language. Dart is a language that's very similar to Java and C# in that if you know either of those languages, then you'll pick up Dart really easy. But also Dart, the ability of Dart to compile into native binaries makes the developer experience when you're building and deploying Flutter applications really, really fast. It has stuff like hot reload. It has the ability to change things on the fly and see them reflected in the application quickly. And then finally, Flutter has a very simplified way of thinking about an application. It thinks about everything inside the application as a widget, which again simplifies that developer experience and makes it a real joy to build in. So let's start with a demo of how to get started with Flutter. Here I've got my Visual Studio Code on the left-hand side, and on the right-hand side I've got an iOS simulator. I've installed the Flutter SDK, and I'm going now to check to see if it's installed correctly. I do that by running Flutter Doctor. Flutter Doctor gives me a nice little output on what is installed, and green ticks that I have here means everything is installed correctly, so I can start building. In Visual Studio Code itself, I've installed the Flutter plugin, and I'm going to use the Flutter plugin to create my first application. I'm going to, once I create the scaffolding for this, my first application, I'll take you through the sections of what make up a Flutter app. First of all, on the left-hand side, we have folders called Android and iOS that contain all of the device code. So you can also open these folders inside Xcode or Android Studio and they would still run. Also, we've got a test folder, a web folder for our web deployment, and our dependencies are managed inside pubspec.yaml. The main entry point to a Flutter app is the main.dart. Here we define statefuls and all our widgets. This first app has a counter. So it's inside a stateful widget, which the state of the stateful widget is the counter. So every time a floating action button is executed, the counter will go up by 1. So I'm demonstrating how easy it is now to deploy that code into my iOS simulator on my right-hand side. Once it's deployed, I'll start executing the app or exercising the app. Very simple. The counter goes up every time I press the floating action button. Also available to me is the widget inspector, which shows me all the widgets I have inside my app so I can quickly debug the UI and layout problems that I may be having. I can also make use of the hot reload function inside Flutter and inside Dart to remove and change my title. So I'm changing my title and see that changed in seconds. And I can also add breakpoints and do the usual things that you do when developing and stepping through your code to find out where those pesky bugs are. So you can see the developer experience is really nice. Also, I'm now going to demonstrate how you can deploy your Flutter application to another device. So in this case, I'm deploying it to Chrome, a Chrome website, and I'll show you how similar this application will be, whether it's running inside Chrome or it's running on your iOS simulator. So here's my Chrome web browser, very familiar app to everybody. The breakpoints still work that I set earlier, and the increment counter still works. But let's see what that looks like if we put them side by side. My iOS that I deployed earlier and now my Chrome deployment. You can see the application are identical in every way, how they execute and how they look and feel. So today I'm going to take you through how to build a specific application. So what are we building? So this application we're building today is the MyShoppingList app. It has a display list screen, it has an add item screen, and it has a buy item screen. So the whole idea of this app is if you're going shopping and you're part of a household, you can create your list, and then when you go to the shops, you can check that list off. But also, this application can be used by any member of the house, and they will add to the shopping list, and if they go shopping by themselves independently, they can shop for the items and check them off, which paralyzes the idea of shopping. Also, a requirement of this application is it will work offline first. So whether it's connected or disconnected to the internet, it will still work. So let's see how we're going to build this out. We'll start with building the application UI using Flutter. So we're back into our project. I've created I've fleshed out main.dart a bit more and started to think about how my project is going to look. So if I go into main.dart, you'll see I have my shopping list app, which is a stateful widget. Inside that, I need to create some state. So I'm defining my state. And inside that, this time, I'm defining some theme data. So how my application is going to look and feel. And the home screen is going to be a new widget called Shopping List Item View. So let's go into that class and start building it out. So the first thing I need in this view is a constructor. And inside the constructor, again, this is a stateful widget, I will build the state. So let's create the state next. There we are. So there's the state. So inside the state itself, we have got a title controller and we've got an override build method. So the override build method is where I'm defining my scaffold. So a scaffold is how I can organize widgets within my UI. And inside that scaffold, I've got two widgets. I've got my nav bar and my floating action button. The nav bar, which I will define now, is very simple. It has my shopping list as text at the top of the screen. The next widget I'm defining is my floating action button. So this is the big plus that I want to click. The floating action button, it defines an icon, which is what you'll see, icons.add, which is one of the default icons within Flutter. And on pressed event, it will pop up another widget called New Item View. So let's finally define New Item View. The widget New Item View is a column inside which is a text field where you can enter your groceries, and also has a button. So when you click the button, you want to add that grocery to the list. So that's the UI defined. Let's deploy it into my iOS simulator on the right and see how that looks. So there it is deploying. First I can check the widget inspector to make sure I've got the widgets that I expect. So I've got my scaffold, app bar, floating action button, and my icon. Very good. So let's exercise the app. Floating action button, put in some text. So I'll buy some cheese, and then a button that I can add some cheese. So I need to obviously implement the onPressed event, but that UI is looking nice and exactly what I want. So the next stage in our application development cycle is to think about how am I going to store the data of my shopping list? And then how am I going to have that data available offline and online? And to do that, I'm going to use AWS Amplify. So AWS Amplify is a way that you can configure AWS backends really, really fast. But also how you can seamlessly connect existing front ends to backends. And we do that using a number of means. We do that using the Amplify CLI, and we also use the Amplify admin UI as a way of configuring those backends. And then once they're configured, we use the open source libraries and UI components that Amplify supplies, which are all up on GitHub, so you can all contribute to them, to then connect my application that I'm writing to the backend that I'm provisioning, all using Amplify. In the Amplify feature categories is what Amplify can add, the feature that Amplify can add to your app. So they are a way of encapsulating users or user behavior and functionality inside your app. So feature categories we have like authentication, APIs, storage, all can be added to your app using Amplify feature categories. Today we're going to concentrate on one feature category, and that is Amplify DataStore. So let's find out what that is. Amplify DataStore is a way of adding data flow to your app, not only in a disconnected state, but also connected state. So as an offline first approach, it's ideal. It provides a simple set of APIs that you can create CRUD operations on a data model. It also works locally. So if you're running on an iOS device, the data that you persist through the DataStore API will be stored in a SQL-like database. And also, it will work in an offline first capacity, i.e. you do not need a backend connection for it to work. So let's see how we build out that data model using DataStore. So here I've got the Amplify sandbox. This is a website that you can navigate to without having the need to have an AWS account. Sandbox.amplifyapp.com. Here I want to create an app backend. From here I can either pick a feature that I want to create. I'm going to create some data or a data model. Once I click that, I'm provided with some schemas. I'm just going to go blank and start from scratch. And this brings me to the data modeling UI. I can add a model. So shopping list I'm creating, so I need a shopping list item model that will contain my items. You get an ID for free, and also so every shopping list item, it needs a name. So I'll call it item name, and the name of a shopping list item will be a string type. I'll also need a way of flagging, is it purchased or is the item being bought or complete? This will need to be a Boolean type, so I'll define that as a Boolean. And also I'll mark the item name as is required, because a shopping list item needs a name for it to be something. Next, the Amplify Sandbox will take me through how I can set up my particular Flutter project to use the Amplify DataStore feature category. First of all, it shows me how to install the Amplify CLI, and then it shows me how to pull down the data model that I've just generated in the UI. So I copy that command, I go back to Visual Studio Code, and the Amplify pool will pull down my data model, generate these types and the schemas in a Dart file for me, so that I can then refer to them and reference them when persisting. So that's all done for me. All of that scaffolding code is created. Next, I install into pubspec.yaml all my Flutter dependencies, which I'm doing here. And then I will go and update the iOS and Android folders to set the minimum version that we need to have DataStore working, or Amplify working. There we are, so that's iOS done, and we do the similar thing for Android inside build.gradle. Next, we need to go into main.dart and configure Amplify. So again, I'm copying and pasting all the code that's been supplied into my main.dart, and it's configuring the Amplify library so I can start interacting with them and using them to create my data model and create my data store. So I've got a init state override, and inside my init state method, I call configure Amplify. I'm just copying and pasting the code that's been provided, all of the scaffolding code that I don't have to think about that's been provided that I can just reuse and move on to adding my feature. Okay, so now I've got that configured. The next thing I need to do is I need to call the DataStore API. So I'm going to do that inside a repository. So I'm implementing a repository pattern. And a repository is a great way of abstracting the complexities of where you want to call your underlying data model away from the UI or anything else. So I'm going to define 3 methods in here called getListItem, createListItem, and updateListItem. So standard CRUD operations. And inside that, these I'm going to call the DataStore API methods. And what are they? Well, again, these are provided for me. So I choose the one I need. So I need a query first in getListItems. So I copy and paste the code, and then I'm just going to fix it up so it's clean and it works inside my particular application. So I make the method async. I tidy up its return type. I make sure that I define it as a future, because that's how we define asyncs inside Dart. And then I'll format it as well. And then I'll do the same for the create list item. It takes an item name, because that's our mandatory field. And then I'm copied and pasted this code across from the sandbox. Again, tidying it up, making it async. Of course, the obligatory try catch block. And then finally, the update list items. Define, so update required. The only thing that's going to be updated is the flag is completed or is purchased, and that's passed in. And then I find the item that I need to update, and then I set the update. Again, tidying it up, async, try catch block, like so. So here we've got our get list items, we've got our update, and all is good. So let's see how that works. So if I F5 this application, so it deploys into my iOS simulator, you'll see that we now have our UI as expected, and we press the floating action button, we will get again our ability to add a shopping list item. Cheese. Now the onPressed event actually populates the data model. So I've got added cheese and crackers to the data model. I can set the flag of is purchased or is complete, and it all works nicely. And it's all working in a disconnected state. So that's great. So a quick reference to the block pattern. If you've never used Flutter before, you'll come across the block pattern as a way of separating your events from the UI into the actual actions, in this case in a repository to DataStore. And the block pattern is a reactive pattern. So if you're familiar, you've done some React programming in the past, it'll be very familiar to you. So on that, if you go from top to bottom, we have our UI, which is our onPressed event. It delegates to our block, which will then create list items, which will then delegate back to our repository. So that abstraction is a great pattern to use, and it's very easy to use. So if you're building Flutter, have a look at it. The next stage in our journey is to go past our disconnected state with DataStore into our connected state. So DataStore, once it has a backing services, so AWS Amplify has deployed our managed GraphQL service, which is AWS AppSync, and our Amazon DynamoDB, our NoSQL database, then DataStore will start syncing the data between the front end and the back end using a sync engine. It will use GraphQL queries and mutations to update the data in the back end, and it will subscribe to subscriptions to pull to get data back into the device. So let's see how we do that. So here we are back in Sandbox. We simply hit deploy to AWS, which will deploy our AWS AppSync instance and our Amazon DynamoDB NoSQL database for us. So here we are in the admin UI for Amplify. You can see it's deploying, and we have a number of things that we can do here, but for our intents purposes, we're just concentrating on data and content. Once it's deployed, we can pull down this configuration locally, so we can start interacting with this backend we've just provisioned. Again, we use Amplify pull, and we give an app. We define what sort of IDE we're using, where all the code is, and we could also given the option of we could use the CLI to provision this backend as well. Once that's done, we can go and start creating content. So a feature of the admin UI is you can create content that will be persisted in the DynamoDB instance. So here in my simulator, I'm creating content on the right-hand side. If I refresh content in admin UI, you can see it appears. So cheese is there. Similarly, I can add crackers in the admin UI, and it should then appear in my app. It's not, so we're missing something. So if I refresh the app, it's there, but it's not picking up that notification or that subscription. Why is that? Well, we need to implement an observer on the shopping list item. So that's pretty easy to do. We go into our repository and we wrap the DataStore call that we need. In this case, it's amplify.datastore.observe. We then pass in the type that we're observing. So this is a shopping list item. And then we need to return a stream, which is how events are used inside Flutter. We then go into our block, define the same method. So remember, this is how we're decoupling our UI from our DataStore calls. We define that observe items method, and we act on the stream. So once we get something in the stream that is a shopping list item, we need to do something. So the thing that we're going to do, we're just going to reload all of the items, which is a nice way of just refreshing the list. Here we grab the stream that we're listening to, and we define what we're going to do. So we're going to re-get the list. Then finally, we add that observe call into the UI. So here we have our block provider. It's already doing get list items. Let's also add observe list items. So let's see what happens now. Here we are, deployed our change, hot deployed our change, and let's create another item in the admin UI. Milk. And you'll see it appeared all right away in the right-hand side. And then we can also update flags. So our is complete flag we can update here. And you can see it updates on the right-hand side as well. We can also then start deploying to other platforms. So let's see how this application works on iOS and Android. So on Android, let's create some bread. And it's created, hit bread, and it's shopped for. So there we have that cross-platform, offline first application built using Flutter and AWS Amplify. So that worked out well. We were able to build out our application from a single code base. We were able to not even worry about connection state. Amplify DataStore did that for us. We didn't need to worry about scaffolding. The sandbox, we copied and pasted that code across from Amplify Sandbox, and it all worked. Then we didn't have to worry about data synchronization. Again, once Amplify DataStore was in a connected state, it synchronized the data for us. It also handled conflict detection and resolution, and all of the complexities that we'd usually have to code for ourselves. So it allowed us to actually concentrate on the value add features of MyShoppingList, the ability to walk into a shop and to parallelize the act and chore of shopping. So the application, if you want to have a look at it, it's on my GitHub repo. Feel free to pull it down. And also, if you want to start thinking about what else you can build and what other modern applications you can build on AWS, we have a great resource here in the resource hub that you can use. We also have a depth and breadth of training and certification courses that you can take to help increase your knowledge on the platform. So thanks for watching until the end. My name is Derek Bingham, developer advocate at AWS. My Twitter handle is here. If you want to reach out anytime, please feel free to do so. Other than that, I'll see you next time. Bye.